All right, section 4.2, number 11D, we are solving factorial equations here, trickiest part of this lesson. And certainly we have this extra little added thing right here that I think has tripped some of you up, is this 3 here. Like, what do we do with the 3? How does that factor into these equations? Well, what we have to do is we have to divide this 3 off. Now you can do it now or you can do it later, but we can divide both sides by 3. Divide both sides by 3, and you can do that right away at the beginning if you want to move that 3 over to the other side. So really the one added wrinkle is this 3, but all you do is divide both sides by 3. So instead of 126 over here, we actually have 42 over here. Okay. Now when this 3 is gone, this should be fairly familiar. And what you do is you expand the top and expand the bottom out a little bit until you get something that's the exact same on the top and bottom that you can divide out. So we subtract 1. So here's n plus 1. Let's subtract 1 and multiply. So that is just n. And then we go again, n minus 1. And I see n minus 1 on the bottom. So now I can just say, hey, we're going to keep going this process, subtracting 1 all the way down to 1. And I'm going to write the top like that. And on the bottom, of course, I have n minus 1 factorial. And of course, this still equals 42. All right. Now we're getting close. We can see that we have n minus 1 factorial as a factor on top and on the factor on the bottom. So we can divide those out. And we're left with n plus 1 times n equals 42. We multiply that out, and we have n squared plus n equals 42. And we're getting close again to the quadratic equation. So we have n squared plus n minus 42 equals 0. And please remember, you have to have the equals 0 over here on the right side in order for the zero product principle to work or for the quadratic equation to work. So zero product principle says that we need to try and write this trinomial into factors, 2 binomials. And what we're looking for is we're looking for 2 numbers that multiply to negative 42 and add to positive 1. So the numbers that multiply to negative 42 would be, let's say, 7 and negative 6. So I put an n here and an n here because n times n is going to have to equal n squared. And then I simply use those 2 factors and complete my binomial. So what I say, positive 7 and minus 6. That's how you factor that. So you do a quick FOIL method now. You do n squared, negative 6n plus 7n gives us positive 1n. And then 7 times negative 6 is negative 42. So it looks like my answers can either be negative 7 or positive 6. That's what happens. That's the numbers I have to put in here to make each one of these equal 0. And that's how I get my possible answers. And like I say, we've done this before, so you might have to go back and look at some examples or look at some previous videos if you want a little more explanation about this. But we reject negative 7 because we don't want any negative numbers. We can't take negative the factorial of negative numbers. So we're looking at 6. Okay? 6 appears to be our answer. Now you do want to check that. And so let's do 6 plus 1 factorial over 6 minus 1 factorial should equal 126. And we're going to multiply that by 3 over here. So let's see if that works. 3 times 7 factorial over 5 factorial equals 126. If I divide both sides by 3, I know I get over here, I know I get 42. So 7 factorial can be written as 7 times 6 times 5 factorial divided by 5 factorial equals 42. And I'm almost done here. The 5 factorials cancel out, and I have 7 times 6 equals 42, and that is correct. So my answer is n equals 6 for this factorial equation. Okay, you guys have any questions for me there? No? Okay, so the added wrinkle of the 3 as a factor over here, just divides both sides by 3 at the very beginning if you want, then it becomes a little bit more like the ones we've done.